Give a heading, sketches in kinematics. Distance or displacement time sketches. I'm first putting distance or displacement give a heading, distance time sketches.
Done.
Distance time sketches. Now look at the point. The gradient shows speed or velocity. Area does not show any physical quantity. Now this is to remember that area is the product of the two axes, and area is the product of the two axes. Area is the product of the two axes, and gradient shows speed or velocity. So here area is not showing anything. So please copy these 2 points. Have you copied it? Gradient shows speed or velocity. Area does not show any quantity.
Done.
Now, remember these sketches. You can't remember all the sketches in physics. So how you can tackle this type of questions? Remember that the main sketches I had asked you to copy in our yesterday class. Remember this work we have done. This is the main work. You can't remember the sketches. So remember these sketches, which are called template sketches. If you remember the template sketches, you can actually manage all the sketches in your course. So now you have to copy these sketches, this whole screen, and I'm just coming, copy this whole screen.
And
Have you copied it?
yes,
Now I'm putting a sample sketch after copying that. You're not supposed to copy this. You have to tell me from the notes you have just copied. You have to tell me what's happening in OA. This is a distance time graph. Tell me what's happening in OA.
the velocity is constant
Velocity is constant. Very good.
and the acceleration is zero.
What's happening in AB?
It's at rest.
Very good. And BC is the same. So look, OA is constant velocity. AB is not moving, it is at rest. Now look at this example. A ball is thrown upward. When it is going upward, the velocity is decreasing. It reaches the maximum point and then it falls down. In the downward journey, velocity is negative and velocity is increasing. A small solid ball is thrown vertically upward. So copy this screen.
Done.
Now, when you throw a ball upward, look at this screen. When you throw a ball upward and it comes back on the same position, look at this screen. A ball is thrown upward and now it's coming back. This is called the case of vertical motion, and the shape of the graph is showing the velocity decreases for the upward motion. For the upward motion, velocity is decreasing. For the downward motion, velocity is increasing. So now copy the sketch.
Why is velocity decreasing at point A?
When you throw something upwards, and just imagine if you play any game, if you throw something upward, it will gradually slow down. That is why it comes back now. The gravity is opposing it. So when you throw something upward, it will be slowing down. When you throw something upward, it will be slowing down. And when it is coming down, it will be accelerating. Why? If you jump from a height, why you accelerate downward? Because gravity is attracting you. Throughout the motion, acceleration is constant and it is equal to g. Trend in acceleration is the trend in resultant force. Now, this is our next concept. Whatever trend is for acceleration, it will be the same trend for resultant force. That is that if you find what acceleration is doing, same will be the resultant force. You have to copy this.
Done.
At the turning point of a curve, gradient is always zero. Now give the heading speed time sketches. Give the heading speed time sketches. Gradient shows acceleration, a very important thing which comes very oftenly in the paper. It comes very oftenly in the paper. So copy the screen. Gradient shows acceleration. Area shows distance traveled.
Done.
Now, velocity time or speed time graphs. Look at this screen. These are called speed time graphs. They are to be remembered, and obviously they all belong to the same shapes. You have to copy this. I'm just coming, copy this. When the line is straight and it's going upward, it shows constant acceleration. Remember, when a line is parallel to x-axis, when a line is parallel to x-axis, When a line is parallel to x-axis, it shows zero gradient. Have you copied it?
Yes.
Good. So a ball is falling down and acceleration is constant. Look, the ball is falling and look the sketch. It is a straight line. Now give a heading, calculations for distance traveled and acceleration. You have to copy this heading. Look at the first calculation. That is the famous calculation for gradient. Gradient of velocity time graph. Gradient of velocity time graph shows acceleration. This is a very common calculation when you're doing past paper. In MCQs, commonly it's there. So you find the gradient from a velocity time graph to get the acceleration. So now you have to copy this.
Time.
So this is how we calculate the gradient, and we use gradient for getting acceleration. Second important calculation is area under a sketch. A very famous calculation again, which is coming very oftenly in the paper. That's a velocity time or speed time graph, and we can get the distance traveled by the area. So you have to give this heading now.
Done.
In this case, this is an example, and the shape is a trapezium. Such questions you can solve. You are a math student also. So you can use either the concept of trapezium, or you can use a triangle and a rectangle. So it's your choice. I will prefer obviously trapezium because it takes less time. So copy this screen.
Done.
Look at the working.
Done.
So in case of a curve, you can use box counting method where you can, this is called a box counting method. So when you consider a box counting method means you have to make the, in a real graph paper, there are boxes. So you can count the boxes, area of one box into number of boxes. We use that. You have to copy this.
Done.
So now, example, a ball is thrown upward without air resistance. So this is a famous example. We did this example for distance time, but now we are doing for speed. When the ball is going upward, speed is decreasing. And when the ball is coming down, now you have to copy this.
Done.
Look at the graph. The speed is decreasing when the ball is going upward, and the speed is increasing when the ball is going downward. You have to copy this sketch.
Speed is increasing when the ball goes down.
Sorry.
Speed is increasing when the ball goes down.
When it is, look at the screen. When it is coming down, speed is increasing.
Yes.
Memorize it. When something is going upward, when something
Yes.
is going upward, speed is decreasing. Now, example number next. A cyclist is traveling. There are two patches of the cyclist motion. So you have to copy this screen.
Done.
Can you tell me what's going on in OA? Can you describe OA?
Increasing acceleration.
OA is increasing acceleration. Good. AB, velocity is increasing but a decreasing rate.
Done.
Now, copy this screen. I'm just coming, copy this screen, and you're supposed to explain the graph for me. Look at the patches. The first patch, object is at rest. Then there is a quick acceleration. Then velocity becomes constant. And then there is a deceleration. Update the screen. Let me know once you have copied it. So now you have to change the page. You have to give a new heading. Dynamics.
I can't see screen.
Oh, actually. Let me check. Give the heading dynamics.
Done. Done.
This is our new chapter.
Are you sharing the screen?
I'm trying to, not working yet. Just a minute, please. Give a new heading dynamics. This is our new chapter. This is also coming every year. Normally it comes with the kinematics. Kinematics and dynamics, they come together. I'm first putting the main topics of this chapter: Newton laws, mass, weight, and inertia, circular motion, and momentum. Momentum is a new topic. So I have to copy this list.
Done.
Newton's laws of motion. Give the heading. Newton's laws of motion. These are very famous, and we are listening them from our earlier classes. There are three laws Newton made. The first law says that if something is in motion, Newton said that if an object is in motion, it will remain in motion, and if an object is at rest, it will remain at rest until an external force is applied. So Newton had a point of view that if something is moving, it will be moving forever. Like in space, this happens. So if something is moving, it can move forever if there is no external force. If there is no external force, an object can move forever. Similarly, if an object is at rest, it will remain at rest forever until you apply a force and you make some change. So now you have to copy this screen. Sorry, first give a heading.
Done.
Newton's laws of motion, give this heading, and then first law,
I've given this.
and then copy this screen.
Done.
Now, give a heading, inertia. Inertia is a connected concept. Actually, Newton's first law is commonly called the law of inertia. What inertia means the concept of inertia is the ability of an object to hold itself. Like we are sitting in a car and the car suddenly brake. So we will get a forward jerk. This is inertia. When you are sitting in a car and the car suddenly move, we get a backward jerk. That is the reason seat belt is very important, because it controls the inertial issues. So now give the heading inertia and copy this screen. Like this is a coin on a glass. If you click the card, the coin falls in the card. The coin falls in the card due to inertia. This is a very interesting experiment showing inertia. Inertia in physics has no formula, no unit. Inertia depends upon two things, mass and speed. For example, a train, inertia is due to mass and speed. A bullet is only, the inertia is only due to speed. A multi-wheeler trailer is the inertia is due to its the speed. Sorry, multi-wheeler, the inertia is due to mass, even though it's not moving fast, but inertia is there. You have to copy this. Now, now right under it, for example, when a moving car applies brakes, when a moving car applies brakes, the passengers get a forward jerk. The passengers get a forward jerk give a heading, balanced forces, give a heading balanced forces. This is our new title, balanced forces. This concept means when forces are balancing each other, this is called balanced forces. Give a heading, balanced forces. And just leave it till here, balanced forces, and we will inshallah continue this in our next class. Allah Hafiz.